So for that first subgroup, we have 6 samples with defects. In the column here, we have 6. So defects, they're rejects, right? Whereas, so of those 6, one sample has 3 defects. 2 samples each have 2 defects. So 3 plus 2 plus 2 is 7, and then we have 3 more. Remember, we were doing this whole thing. It said if one has 3, another one has 2 defects, another one has 2, and if we read the case study, it says for the remaining, unless otherwise noted, they all have 1 nonconformity. So this one right here, 5, would have, it would be 1 plus 1 plus, all 5 of these have 1 nonconformity. 1 plus 1, okay? So what is this column D? Let's just talk about column D. What is it telling us? Is that P or NP? Are we going to use that to calculate P or NP? So this is NP. And to get P, we would put 6 divided by 50. So yeah, we're going to use these numbers to get P. So how are we going to calculate the center line for an NP chart? So we're going to take the sum of all of these NP values, okay? And we're going to take the sum of all of these right here. Actually, if we're looking for the average, isn't the quicker way to just go average? Remember with variable control charts, we were saying there's 2 different ways to calculate these center lines. So the average out of all of these NPs is 5. Now to move on, we need to get, we have almost everything we need to solve for this problem right here. Now we have the average NP. We just need to figure out this initial P value. Okay, so what we're going to do, and that should have a line over it. Okay, so how do we figure out the P bar for all of these? Well, you know how to do that. Based on the last couple lectures, we're just going to take NP and divide it by N. So this is P. Proportion non-conforming. Okay, and we'll drag that down. Easy peasy, lemon squeezy. And then we're just going to calculate the average here. Okay, so the average P-bar is 0.1. That goes into that formula. So to get the upper control limit, it's going to be this NP plus square root it'll be NP times 1 minus the initial P. $7.12. And if you're eyeballing it, it makes sense, right? It's bigger than the center line. Okay. And then for the lower control limit, same thing, except we're going to subtract. It'll be P minus square root NP times 1 minus P. 2.87. Oh, shoot. You know what? We forgot to put the 3 in front of the square root. Aha. There we go. 3 equals 3 times There we go. Okay, here's a good lesson. Okay, here we go. When you're doing NP, do not put 50 where N is, because NP is number non-conforming. Sometimes people make that mistake. Does that make sense? Because each one of these, like this is NP1, NP2, NP3, NP4. There are 21 NP numbers, number non-conforming values here. But to get that, you could go 0.12 times 50 is the same as 6. Like here, we have 0.1 times 50 is 5. So N, that's why we call it NP. You take